Okay. Can you see my screen?
Yeah.
Okay. So exercise 5.1 coordinate geometry. The question number 1. Find the area of the triangle formed by the points. They are asking us to find the area of the triangle by using 3 coordinate points. Let's see the solution. I'll discuss the first subdivision. Okay, second subdivision also follows the same method, so we don't have to discuss that. I'll discuss the first subdivision alone. Okay, so the solution. So first thing is we have to mark the coordinates on the graph. Okay, so 1 comma minus 1 comes here, minus 4 comma 6 comes here, minus 3 comma minus 5 comes here. So you need to connect all the 3 points. It creates a triangle. So now our goal is to find the area of this triangle. Okay, we need to find the area of this triangle. So the first step is to draw a graph and marking the points to form a triangle. The formula is area of the triangle ABC. When they give you 3 coordinate x1, y1, x2, y2, x3, y3, you have to substitute in the formula. Half into x1 into y2 plus x2 into y3 plus x3 into y1 minus x2 into y1 plus x3 into y2 plus x1 into y3. So this is the formula. So you just have to substitute in the formula for finding the area of the triangle ABC. So you will assume the very first coordinate as x1, y1, and the second one is x2, y2, and the third one is x3, y3. So now you can make the substitution on this formula. So if you substitute and simplify, we'll get the answer. And at last you have to mention your answer along with the unit. So you have to write square units for the area of the triangle. I hope it is clear. We'll move to the question number 2. In the question number 2, they're asking determine whether the sets of the points are collinear. What do you mean by collinear?
They all lie on straight line.
All the 3 points will lie on the straight line, isn't it? So we do have 3 points here. 3 points here. Minus 1 by 2 comma 3, minus 5 comma 6, minus 8 comma 8. So we do have 3 points here. So let's see whether all these 3 points lying on the same line or not. Now we are going to use the area of the triangle formula over here. Imagine you're having a triangle like this. What if the red line falls on the black line? I mean, assume you have a triangle like this. What happens if the red line falls on the black line? Falls on the black line. Again, it creates a straight line. Straight line. For example, like assume this is x1 comma y1, x2 comma y2, x3 comma y3. If the x3 comma y3 falls on this line means the area of the triangle is demolished, isn't it? The area of the triangle became 0. It has reduced from 2 dimension into 1 dimension, isn't it? So by equating the area of the triangle to 0, you will be able to find whether the given points forms a collinear or not. Is it clear?
Yeah.
So you just have to equate the area of the triangle to 0. Okay. For finding the Collinear. So you know the formula already. So just substitute in the formula. You have to just go by order. So the first point is going to be x1. Actually, this will be your x1, y1. Here it is wrong. It's x1, y1. The next point is x2, comma y2. The third point is x3, comma y3. This is how it works. So you just have to substitute in the same area of the triangle formula. Is it clear?
Yeah.
So just check whether you are getting the answer as 0 or not. So at last, after substituting in the same formula, you are getting the answer as 0 square units. So from that, we can say the given points are collinear. Is it clear?
Yeah.
Okay. Okay. Can you try the second subdivision? Okay. So the question number 3. Vertices of given triangles are taken in order and their areas are provided aside. In each case, find the value of P. So here, some of the points are unknown. Okay, the unknown points being marked as P. So 0, 0, P, 8, 6, 2. So there are 3 coordinate points. Here, this P is unknown. Area is already given. So from this data, we have to find the value of P. Okay. It is very obvious to use the area of a triangle ABC formula again. So you will be using the same formula, just substitute in order. Okay. Okay, I'll just write the formula. Can you tell me the formula, please? Half into
x1
yeah
plus x1 y x1
y2.
x2 x3 x1 at that arrow diagram I'm saying.
You're saying the arrow diagram.
Yeah.
Can you tell me the one-line formula? Okay, no problem. You tell me the arrow diagram. No issues. Anything is fine. Okay, x1.
x1 x2 x3 x1 y1 y2 y3 y1.
Okay.
So
This is how it
x1
goes.
yeah, like that, that's all.
Like that. Yeah. So it's half into what is x1? X1 is 0, y1 is 0, x2 is p, y2 is 8, x3 is 6 and y3 is 2. So you have to substitute in order, isn't it? So 0, p, 6, 0. Y1 is 0, 8, 2, 0. Okay. So it's going to be half into 0 going to be 0 only. It's 0. Minus 0 again. Yeah. Plus p into 2. 2p minus 8 6 are 48 plus 6 into 0 is 0. 2 into 0 is going to be 0 only. So it's half into 2p minus 48. That is how we'll deduce, isn't it? So it's 2p minus 48. So we know the value of area already, which is given as 20. Okay. So 20 is equal to half into 2p minus 48. Take the 2 to the other side, 20 will become 40. So 40, 2p minus 48. Again, for the simplification, it's going to be 2p is equal to 40 plus 48. 88 is equal to 2p. So p is equal to 88 upon 2. So that would give you the result as 44. So the value of p is nothing but 44. So that's our answer. 44. Is it clear?
Yeah.
Okay. I assume you understood the subdivision 2 also. It follows the same method. We'll move to the next question. In each of the following, find the value of A for which the given points are collinear. So this is also a same kind of question. This is a combination of question number 2 and question number 3. Okay. So in question number 2, we discussed about the collinear. In question number 3, we discussed about finding the value of an unknown point. So here, we know this concept already. For finding whether the given points are collinear or not, we will just equate the area of the triangle to 0. So you just have to equate the area of the triangle formula to 0 and substitute these points in order. In order means this is going to be x1, y1, and this will be your x2, y2, and the last point is going to be your x3 and y3. Can you try the first subdivision?
Okay.
Yeah.
I found A, it's 4.
You found A, the A is 4. You're not getting 0?
Oh, sorry, I did that wrong. Oh, yeah, 0 only.
Okay. Second subdivision also follows the same method. We'll move to the next question. Question number 5. Find the area of the quadrilateral whose vertices are at -9, -2, -8, -4, 2, up to 1, -3. So they're asking us to find the area of the quadrilateral. Okay. So here is the area of the quadrilateral formula. It's half into x1, x2, x3, x4. Again, you will write x1, y1, y2, y3, y4, y1. Okay. So again, you'll perform the cross multiplication. So you will take the points in the given order. So this is going to be A, the -8, -4 going to be B, and this is going to be C, and this is going to be the last point, which is D. So let's substitute them over here. So after the substitution, let's do the calculation. So it's -9 into -4, which gives you +36. 2 into 8 gives you -16, isn't it? -16. They wrote the -16 over here. And then -8 into -3 will give you +24. -4 into 1 will give you -4. 1 into 2 is 2. -3 into 2 is minus of minus will turn into plus. So minus of -6. 2 into -2 going to be -4. 2 into -9 is -18. So you just simplify this. This will turn into 58. This will turn into -12. Minus of minus will become +12. So that will give you the result as 70. So half into 70 will give you the result as 35 square units. Is it clear? Subdivision B also works with the same method. Subdivision. Question number 6. Find the value of K if the area of the quadrilateral is 29 square units whose vertices are -4, -2, -3, K, 3, -2, and 2, 3. So 4 vertices are given. Here also you have to take the coordinates in order. Okay. So write the area of the quadrilateral formula and substitute in the respective position. So here you just have to substitute y2 as K. Okay, I'll show you the substitution part. So after the substitution, -4 into K will give you -4K, and -2 into -3. So upward arrow mark will put minus sign before. So -2 into -3 will give you +6. So now let's take this set. -3 into -2 will give you +6. Upward arrow mark, you have to include negative sign. 3 into K will give you 3K. Let's take the third set. 3 3s are 9. -2 into 2 will give you -4. And for the upward arrow mark, you have to include one more minus sign. So minus of -4. For the last set, it's 2 into -2, which will give you -4. And for the upward arrow mark, again you will include minus. 3 into -4 will give you -12. Okay. So it's half into -4K -6 +6 -3K +9. Minus into -4 will give you the result as +4. -4 minus of -12 will give you +12. Okay. -6 and +6 will cancel out each other. +4 and -4 will cancel out each other. So it's going to be half into -4K -3K is -7K Plus 9 and plus 12 will give you the result as 21. Okay. And area is given already, which is 28 square units. So you can equate this to the area. So it's half into minus 7K plus 21. Area is plus 28. Multiply both the sides by half. The 28 will turn into 56. So it's minus 7K, 56 minus 21, which is 35. So K is equal to 35 upon minus 7, which is minus 5. So the answer is minus 5. Is it clear, Manasi?
Yeah.
Okay. Same method. Question number 7. If the points A minus 3 comma 9, B A comma B, C 4 comma minus 5 are collinear, if A plus B equal to 1, then find the value of A and B. Okay. So 3 points are given here. They are saying that the given points are collinear. And if A plus B equal to 1, then find the value of A comma B. They gave 3 points. So you have to assume these 3, by marking the 3 point on the graph, you can find it forms a it forms a triangle. Okay, it forms a triangle. And they are saying if these points are collinear and A plus B equal to 1, then we have to find the value of A and B. So we know the condition for collinear. We'll just equate the area of a triangle ABC to 0. Okay. So you can equate this formula to 0 for solving the first condition. Let's do one by one. Here it should be x1. Okay. So just do the normal substitution and do the calculation. You will be getting this minus 7b minus 14a equal to 21. So from this expression, you can take minus 7 as common, and then it will turn into b plus 2a equal to minus 21. So now I'm going to use the second condition. What is my second condition? They said a plus b is 1. So we'll just see whether is there any possibility to write this b plus 2a in terms of b plus a. So we can rewrite 2a as a plus a. Yeah. Excuse me. It's b plus a equal to, it's minus 7 into b plus a equal to minus 21. So it's b plus a equal to minus 21 upon minus 7. So that will be 3. B plus a plus a. So we know the condition. We know the value of b plus a already, which is 1. So just replace this as 1. So 1 plus a equal to 3. A is equal to 3 minus 1. So a is 2. You'll be able to find the value of b also. It's very simple. B plus a is equal to 1. So we know the value of a, which is 2. So b is equal to 1 minus 2. So that will give you the result as minus 1. So the value of b is minus 1 and the value of a is 2. Can you follow?
Yeah.
Okay. Do you have all the question in your exercise? 5.1?
Yeah. All 11 questions.
All 11 questions. Fine. Question number 8. Let P 11,7, Q 13.5,4, and R 9.5,4 be the midpoints of the sides AB, BC, AC respectively. of the triangle ABC. So there is a triangle ABC. Triangle ABC. Midpoint of AB is P. Midpoint of BC is Q. And midpoint of AC is R. Okay. We know the formula for the midpoint. It's x1 plus x2 upon 2, y1 plus y2 upon 2, which means you just have to add these two corners, the respective coordinates. Like you will add this x1 and x2 and divide it by 2. You will add y1 and y2 and divide it by 2. So that x1 plus x2 by 2 is equal to 11. This y1 plus y2 by 2 is equal to 7. Yeah. So we'll equate this x1 plus x2 by 2 to 11 and y1 plus y2 upon 2 is equal to 7. Okay. So from this we can say x1 plus x2 is equal to 2 into 11, which is 22. Similarly, y1 plus y2 is equal to 7 into 2, which is 14. So from this you can assume this as equation 1 and equation 2. So let's take BC. Apply the same method. x2 plus x3 by 2 is equal to 13.5. y2 plus y3 by 2 is equal to 4. Is it clear?
Yeah.
So x2 plus x3 is 27, y2 plus y3 is 8. So the equations are 3 and 4. Apply the same strategy for the midpoint AC2. We will have the equation 5 and 6. They are adding all the odd equations 1, 3 and 5 so that you can get x1, x2 and x3. What is equation 1? It's x1 plus x2 is equal to 22. x2 plus x3 is equal to 27. x1 plus x3 is 19. So let's add all the equations. 2x1, 2x2 plus 2x3 is equal to 22 plus 27 plus 19. 22 plus 27, 49, 59, 59 plus 9 will give you 68. Take the 2 outside. 2 is common. It will be x1 plus x2 plus x3 equal to 68. So x1 plus x2 plus x3 is equal to 68 by 2. So x1 plus x2 plus x3 is equal to 34. So let's assume this is the equation 7. Is it clear?
Yeah.
Okay. So now we are going to find the values of x terms individually. You can find the value of x3 by subtracting the equation 1 from equation 7. So what is equation 1? Equation 1 is x1 plus x2 equal to 22. So x1 plus x2 equal to 22. Let's substitute that. It's 22 plus x3 equal to 34. x3 is equal to 34 minus 22. So x3 is 12. So again, you can take the equation 3. In equation 3, it's x2 plus x3 is equal to 27. Substitute this as 27. So x1 plus 27 is going to be 34. X is equal to 34 minus 27, which is 7. So x1 is 7. Is it clear?
Yeah.
So you can take the equation 5 now. x1 plus x3 is 19. So x2 plus 19 is equal to 34. x2 is equal to 34 minus 19. So the answer is 15. Understood?
Yeah.
Follow the same strategy for finding the values of y1, y2 and y3 by solving the even equations. Okay. So we found the values of x1, x2, x3, y1, y2 and y3. You can easily substitute the vertices of triangle ABC by combining x1 and y1. Assume that as A, x2 and y2, which is B, x3 and y3 is going to be C. Yeah. So you got all the vertices of the triangle. And you know the area of a triangle formula also. Substitute in the formula of a ABC. You'll be able to achieve the value of triangle ABC. And they are asking us to find the area of PQR also. What is PQR? This point. So PQR, again you go with the order. P is going to be x1, y1. Q is going to be x2, y2. And R is going to be x3, y3. Substitute in the same area of the triangle formula. So by substituting the area of the triangle formula, you'll be able to get the answer as 6. They're asking us to compare the area of the triangle ABC with the area of a triangle PQR. Yeah. So you have to compare them. If you compare, ABC is 24, PQR is 6. So what is the relation between them? It's 4 times the area of a triangle PQR, isn't it? So area of a triangle ABC is equal to 4 times the area of triangle PQR. Can you follow? They're doing the same thing again over here. It's not required. Question number 4. So in the figure, the quadrilateral swimming pool is shown. And this pool is surrounded by a concrete patio. Find the area of the patio. For finding the area of the patio, what is patio here? This area, isn't it? This is area of a patio. So you're going to find the area of this part. So you can find it using just subtract the area of the swimming pool EF.5.1 from the area of the quadrilateral ABCD. Is it clear?
Yeah.
It's not EF.5.1, it's H. It's EF.5.1. So let's find one by one. Let's find area of the quadrilateral ABCD, and then you can find the value of area of the swimming pool EFGH, and then you do the subtraction for obtaining the value of area of the patio. So you know the formula for the area of the quadrilateral already. Just do the substitution. Already ABCD is given. So this is going to be x1, y1, and this is x2, y2, and this would be x3, y3, and this would be x4 and y4. Okay. Substitute in the formula. You are getting the value of the quadrilateral as 212. An area of the swimming pool EFGH. They're assuming this EFGH also as a quadrilateral. Use the same formula. This E is going to be x1, y1, and this will be x2, y2. G is going to be x3, y3. H is going to be x4 and y4. For A, B, C, D, you followed the anti-clockwise. You do the same anti-clockwise for this also. Follow the same direction. So again, you substitute in the area of the quadrilateral formula. After that, you're getting the answer is 90. So for obtaining the value of area of the patio, you just have to subtract them. So subtract 90 from 212. So that would give you the result as 122. Is it clear?
Yeah.
Question number 10. A triangular shaped glass with vertices A, B, C has to be painted. If one bucket of paint covers 6 square feet, how many buckets of paint will be required to paint the whole glass if only one coat of a paint is applied? This one coat of a paint is unnecessary information. Over here, the first step is going to be marking the coordinates over the coordinate plane, form a triangle, and find the area of the triangle. Okay. So once you find the area of the triangle, you have to divide the area of the triangle by 6. Because they said one bucket of a paint covers 6 square feet. Okay. Is it clear?
Yeah.
So you know how to use the area of the triangle ABC and substitute their values. So you are getting the answer is 60 square units. So just divide the 60 square units by 6. So number of paint cans required are 10. 10 cans. That's it. 10 buckets are required. Question number 11. So they gave you a figure. They're asking us to find the area of a triangle AGF. AGF means they're asking about this triangle. Triangle FED. Quadrilateral BCEG. BCEG. You know the formula for the area of the triangle and area of the quadrilateral also. Here, you just have to figure out the coordinates of the specific triangle and the quadrilateral. That's it. Nothing much in this. It's going to be very simple. Let's do one by one. So let's figure out the area of the AGF first. For finding the triangle AGF, you need to substitute the 3 coordinates, isn't it? So the coordinate A, you go by order. This minus 5, 3 going to be your x1, y1. G, so what is G? G is minus 4.5, 0.5. So that is going to be your x2, y2. And F, minus 2, 3. So this is going to be x3, y3. Okay. So you know how to substitute the area of the triangle formula. Do the substitution. Okay. You'll be able to find the value of the triangle AGF. So the triangle AGF is 3.75 square units. Can you follow this?
Yeah.
Okay. So the next thing is triangle FED. So F is going to be x1, y1, E is going to be x2, y2, and D is going to be x3, y3. Just do the same substitution on the same formula. We'll be able to achieve the results, which is 3 square units. And for the quadrilateral, what is quadrilateral? Quadrilateral BCEG. So B is going to be x1, y1, and C is going to be x2, y2, and E is going to be x3, y3, and G is x4, y4. Same thing. What is the quadrilateral formula? Half x1, x2, x3, x4, y1, y2, y3, and y4. Minus 4 comma minus 2 is x1 and y1. What is x2 and y2? It's point C. Minus 2 comma, plus 2 comma minus 1. x3, y3 going to be 1.5 comma 1. x4 and y4 going to be minus 4.5 comma 0.5. So this is point B. So x2, y2 is C. x3, y3 is E. x4, y4 is G. So just substitute these values over the area of the quadrilateral formula to be able to find the answer, which is 13.88. Is it clear? It's all about this exercise. Do you have any doubt in this exercise? Okay, then we'll discuss the rest in the next class. Okay, shall we stop here?
Yeah.
Okay, Mansi. Thank you.